Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The reaction involves protonation of an alkene, pent 2Na, by H+ to form an intermediate carbocation, followed by loss of H+, deprotonation, to give the final alkene product, double bond migration. This is an acid-catalyzed double bond isomerization. Moving on to the next step. Determine the number of steps and intermediates. The mechanism has two elementary steps. I. Protonation of the alkene double bond by H+ carbocation intermediate, transition state 1 leads to carbocation. 2. Deprotonation of the carbocation product alkene, transition state 2 leads to product. This gives an energy profile with 2 transition state humps and 1 intermediate, the carbocation, between them. Moving on to the next step. The starting material is an internal alkene, pent 2Na, more substituted, more stable, and the product is a terminal alkene, less substituted, less stable, or the reaction is an isomerization where the product is slightly less stable than the starting material. However, since H+ is a catalyst and is regenerated, the overall reaction energy change depends on the relative stability of the two alkenes. The internal alkene is more stable than the terminal alkene, so the product is slightly higher in energy than the starting material, but the key feature is two humps with an intermediate. The carbocation intermediate is high in energy. The first TS, protonation, is higher than the second TS, deprotonation, because forming the carbocation is the harder step. The product is at a slightly higher or similar energy to the starting material, but the profile shows two peaks with the first peak higher. And for the final step, option A shows two equal humps with products at the same level as reactants. Option B shows one hump. This would be a one-step reaction. Option C shows 3 humps. This would require 3 transition states and 2 intermediates. Option D shows 2 humps where the first hump is higher than the second and the products are at a somewhat different energy level than the reactants, consistent with two-step mechanism where formation of carbocation is rate determining, higher first barrier, and deprotonation is easier, lower second barrier, with overall product energy slightly different from starting material. B fails because the mechanism is two-step with an intermediate, not one step. C fails because there are only 2 steps, not 3. A fails because the 2 transition states are not equal in energy. Forming the carbocation requires more energy than losing a proton from it, and the product energy level does not match. D correctly shows 2 transition states with the first TS higher than the second. Carbocation formation is harder than deprotonation. 1 carbocation intermediate, consistent with the two-step acid-catalyzed isomerization mechanism. Therefore, the correct answer is D. Therefore, the correct answer is option D.